Welcome back to The Explainer. I am absolutely pumped you're hanging out with us today because we're jumping right back into literally the most absurdly high-stakes question in physics. Seriously, why does the universe even bother existing? Why doesn't everything just, dissolve into a random soup of cosmic static? Today, we're unlocking the universal cheat code that decides whether something actually gets to persist or whether it just fades away into total nothingness. Okay, let's dive right in. If you caught the first part of this explainer, you might remember we talked about General Emergence Mechanics, or GEM, which is this mind-bending theory by researcher Peter Baldwin. We stopped looking at the universe as just an empty box, and instead looked at it as a giant, dynamic, coherent shell. Picture it like a massive, invisible safety net that anchors all of existence at a very specific mathematical baseline, the 255-degree vacuum minimum. Literally everything you know and love is just trying its hardest to stay balanced inside that glowing shell. But that leaves us with a multi-million-dollar question. How does the universe actually decide what gets to stay and what falls apart? Well, it all comes down to what we're calling the three magic axes. These are three fundamental rules: depth, stiffness, and viscosity, and they act as the absolute judges of reality. And I mean everything, from a burning star to a rubber band right down to your own brain. Everything has to pass the test of these three axes to survive.
Axis 1, depth. Let's talk about surviving under pressure.
So what is depth? It's basically your absolute limit. In Baldwin's framework, depth measures the energy barrier that's needed to escape the local coherence shell entirely. Put simply, it's the maximum amount of punishment, stress, or disruption something can take before it completely shatters and just can't be put back together again. It is the universe's ultimate breaking point.
It's super easy to picture this in real life. Imagine an empty crisp pocket. If you smash that thing with a hammer, it instantly crumbles into dust, right? It has practically zero depth. But now imagine taking a thick, heavy-duty rubber tractor tire and hitting it with that exact same hammer. The hammer just bounces right off. That tire has incredibly high depth. It can absorb a massive amount of stress before its fundamental structure is destroyed.
And the crazy thing is, this perfectly maps onto what happens in our own heads. In the biological extensions of GEM, human depth is basically our resilience. You know how some people can have a truly terrible day, they bomb a test, lose their keys, get completely soaked in the rain, and they just kind of shrug it off? They have high mental depth. Their coherence shell is deep enough to just absorb all that stress. Meanwhile, a person with low depth might get one tiny piece of bad news and completely break down. But hey, life isn't just about massive hammer-smashing disasters, right? Most of our existence is just a never-ending series of annoying little pokes, prods, and pushes. So what actually protects us from all that everyday noise? Axis 2, stiffness. Let's measure that elastic resistance. In Peter Baldwin's math, stiffness, which is represented by the Greek letter kappa, is the local curvature of the coherence shell. Now, in plain English, it's the immediacy and the strength of a system's elastic resistance. Basically, when the universe gives you a little poke, how aggressively do you push back to maintain your shape? Think about the difference between a tightly coiled metal spring and a sad, wet noodle. If you poke that coiled spring, it immediately and aggressively pushes right back against your finger. It demands to return to its original shape. That is high stiffness. But if you poke a wet noodle, it just limply flops over and accepts its new reality. It has low stiffness. It literally offers zero resistance to being changed.
Let's map this one onto your brain. Human stiffness is essentially your focus and your adaptive response. Imagine you're trying to study and your phone buzzes. A stiff mind feels that distraction, immediately pushes back against it, and snaps right back to the textbook. But a noodle mind, it feels the buzz, accepts the distraction, and suddenly, oops, you've been scrolling on TikTok for 3 hours. Your stiffness axis is what determines your resistance to everyday drift.
Okay, so we've got depth to stop us from completely breaking and stiffness to push back against little pokes. But what happens after a poke actually gets through? Like, what happens when you've already been bent out of shape and now you have to find your way back to normal?
Axis 3, viscosity. Let's talk about relaxation time.
Get ready, because this is where things get genuinely mind-bending. Viscosity, which is also called relaxation time, governs exactly how quickly or slowly a system recovers after it's been disturbed. And in general emergence mechanics, this is wild, viscosity is actually what creates the arrow of time. Time isn't just some invisible clock ticking in the background. Time is the process of the coherent shell relaxing back to its resting state. If viscosity was 0, everything would snap back instantly, and we wouldn't even have a past or future. To picture this in action, imagine poking a bowl of water, and then compare that to poking a jar of thick honey. If you poke the water, the ripples disappear almost instantly, right? The water snaps right back to being perfectly flat. It has very low viscosity. But if you drag your finger through thick honey, that groove just stays there. It lingers. It slowly oozes back into place over several minutes. The honey physically remembers the disturbance. And wow, does this brilliantly illustrate human viscosity. Think about how you recover from an argument. If you have low psychological viscosity, you get mad, sure, but 10 minutes later, you're completely over it, just like the water. But if you have high viscosity, man, that bad mood lingers, you hold a grudge, you replay the argument in your head while you're trying to sleep for 3 days straight. Your mind is literally acting like thick honey, struggling to return to its stable baseline. Now, I know what you're probably thinking. Okay, this is super cool for springs and my bad moods, but is this really a universal physics theory? Like, do these exact same 3 rules honestly apply to the entire cosmos? Section 4, the Universal Mechanics Code. It is absolutely fascinating to see this all mapped out together. Baldwin's mathematical persistence parameters govern literally everything. Whether we are talking about the structural integrity of a rubber tire, the resilience of your closest friendship, the routing efficiency of an AI computer system, or even the gravitational structure of a spinning galaxy, it's all the exact same math. It's all just different expressions of depth, stiffness, and viscosity working overtime to keep a system coherent above the persistence threshold. So the huge takeaway here is that existing in this universe is an active, ongoing 3-step mechanic. Step 1, a disturbance hits the shell. Say you have a really bad day. Step 2, your stiffness dictates exactly how strongly you resist that initial shock. Step 3, your viscosity dictates how quickly you recover and drop the baggage. And hovering over this entire process is your depth, just making sure the initial shock wasn't big enough to break you completely. Section 5, which axis is weak? Let's diagnose the problem. Understanding how the universe works is great and all, but understanding yourself through that exact same lens, that is a total superpower. I absolutely love this quote. The universe is basically playing a giant game of don't fall apart. And hey, you are a part of that universe. You are a highly complex, beautifully structured configuration of matter and energy. And right now, you are winning the persistence battle inside the cosmic coherence shell. But staying together, it takes work. So here is your ultimate universal cheat code. The very next time you feel stressed, overwhelmed, or like you're just kind of falling apart, I want you to pause and ask yourself, which specific axis is failing me right now? Are you facing a problem that is just way too big, threatening your depth? Are you getting easily distracted by a million little pokes, meaning you just need to boost your stiffness? Or are you holding onto a grudge and ruminating, meaning your viscosity is too high and it's taking you forever to recover? Diagnose the actual mechanic, and you can fix the problem. You are built from the exact same mathematics that hold the stars in the sky, and I think that is pretty incredible. So I'll leave you with this one question to chew on. What part of your coherence shell needs reinforcing today? Thanks so much for hanging out with me on this explainer. Keep your depth high, and I'll see you next time.